Hi students, now we're going to talk about arc measure and arc length. There's a difference. So an arc measure is the degree measure of an arc that's equal to the measure of the central angle that intercepts the arc. So remember, if we have a central angle of 82 degrees, the arc that's intercepted is also 82 degrees. But 82 degrees is the measure. It is not the length of this arc. If we took this arc and straightened it out, the length is arc length, not the degrees, the measure. So if you remember circumference is 2 pi r, and it's the length, longitud, of the entire circle, de la círculo todos. So the length of an arc is just a fractional piece of the circumference of the circle. So it's a part of the circumference, parte de circumference. When you're finding the arc length, it depends if you're given measurements in degrees or in radians. If you're given the measurements in degrees, you use this formula, where S is the arc length, S equals arc length, and if you're given the measurement in radians, the arc length is also S, but this is the formula. Now look at this formula, x over 360 times 2 pi r, and look at this formula, r theta. Remember, theta is the measurement of the angle. This one looks easier, right? Because it's not so much. So I like to use this one. I just change all of my degrees to radians first, so I can use this one. But I'll show you both ways here. So first, we're going to find the arc length of AB. We take the degrees because this measurement is in degrees, not radians. So S equals 120 over 360. Okay, I'm just following this, times 2 pi r, the radius, which is 6. Now, I'm just going to put that all in my calculator. 120 divided by 360. I just like to hit equals. And then I'm multiplying by 2 pi times 6. And I get 12.57. We round that to a 7. So S equals 12.57 centimeters, because this is measured in centimeters. So that means that this length of arc AB is 12.57 centimeters. Okay, I'm going to do the same problem, but now I want to try using this formula. So I need to change 120 degrees into radians. And if you remember in the last video, to go from degrees to radians, you need to multiply by pi over 180. Okay, so 120 pi over 180. I'm simplifying, getting rid of those zeros. 12 pi over 18. The biggest number that goes into both of these numbers is, I want to say 6. So I'm going to try to divide by 6, and I get 12 divided by 6 is 2. 18 divided by 6 is 3. So this is my angle measurement. This is 2 pi over 3 radians. Now I take this, S equals R theta. R is 6, and theta is 2 pi over 3. So I take 6 times 2 pi over 3, and I get 12.57. So you can do it either way. You can use this formula with degrees, or you can change it to radians and use this formula. Okay, let's look here. The angle is in radians, and we want to find this arc length. So I'm going to use this formula, S equals R times theta. R is 8, and theta is 5 pi over 9. So I just take 8 times 5 pi over 9, 13.96. S equals 13.96, and this is in inches. So this length here is 13.96 inches. If you want to pause the video and try these ones before I do them, you can do that. Here it says the diameter is 24. So that means that the radius is 12. It's half. So I know the radius is 12 centimeters. I see it's in degrees, but like I said, I like to use this formula up here. So I'm going to change it to radians first. 60 times pi over 180. I'm going to get rid of those zeros. 6 pi over 18. And 6 goes into 18 3 times, so that's just pi over 3, because 6 divided by 6 is 1, and 18 divided by 6 is 3. So this is my theta. So now I do S equals R times theta. R is 12, and theta is pi over 3. 12 times pi over 3 is 12.57. And that is in centimeters. So this right here is 12.57 centimeters. All right, one more example, and then you can go finish this lesson doing the practice and the check-ins. So this angle is in radians already. That's good. I'm going to use this formula. S equals radius times theta. Put it right in my calculator. 5 times 4 pi over 9, 6.98. And that is in centimeters. All right.